Good morning everyone. So today we are going to start with the unit 3rd of class 11, that is the classification of elements and periodicity in properties. Before starting the detail of the chapter, first of all we will clear the name of the chapter. That is a classification of element and periodicity in properties. What it says, that what we will do in this chapter, we will discuss that how the elements are classified in the periodic table, okay, and what are the properties those are repeating themselves. Here we are going to talk about atomic radii, ionic radii, nuclear charge, electronegativity, electron gain enthalpy, all those we are going to discuss here, okay. First of all, the first thing which we are going to talk about here, that is a modern periodic table, okay. We will not discuss the few previous tables which are given because our main syllabus start from here only, so we will start from this part only, okay. So first of all is a modern periodic table. The modern periodic table, that is divided into four parts. You must always remember this, that it is divided into four parts. That will be S block, P block, D block and F block. Four things. Okay, periodic table is divided into four parts: S, P, D and F block. Okay, the first part which we are going to discuss here, that is the S block elements. Now, where the S block elements present? If suppose this is the periodic table, I'm just assuming if this is a periodic table, the S block elements will be present this side, okay, this side. That means which side? Left side of the periodic table, okay. They are present left side of the periodic table, and we have divided the, you already know, in the 10th standard we have divided the periodic table into groups and periods, okay. So we already know in modern periodic table there are 18 groups and 7 periods, okay. 18 groups, 7 periods. So first of all we are talking about S block. So to which element we are called S block element? The first question we are having, that to whom we will say S block elements? The group number 1 and the group number 2, okay. The elements those are of group number 1 and group number 2, these are called S block elements, okay. The general electronic configuration of S block, that is NS122. Why it is written NS122? The N represent the principal quantum number. As you have written electronic configuration, so you already know that N would be 1, 2, 3, 4, 5, 6, 7. We are having 7 periods, so N could be up to 7. Right? So and what it says, this is the N is a main quantum number, जिसको हम usually say principal quantum number, okay. So generally we usually write it as a N. So we are writing for both group 1 and 2. The general electronic configuration, that is 1 to 2. 1 will be for which one? If I'll say NS1, this would be for group 1, okay. If I'll say NS2, that will be for group 2, okay. Now to whom? What is the definition of S block? The elements. See the definition which is written over here. The elements in which the last electron enters to the S orbital of the periodic table, okay, S orbital of their outermost energy level are called S block elements, okay. In the periodic table, when the last electron enters in the S orbital, then those are known as S block elements, okay. Now we are going to talk about characteristic of the S block element. Before starting with the characteristic, first of all you already know that we are having some metals in the periodic table. I am not saying here that all the metals are confined to S block only. I am repeating again. I am not saying this, that all the metals are confined to S block. Some are the part of the D block, and we are having metalloids also. Those are the part of the P block. We are going to discuss further. But we are having S block usually composed of what? Metals. And which metals? The metals which are soft in nature, like sodium, potassium. You already know that, you have learned in the 10th standard. You have learned over there that you can cut sodium or potassium with knife. Why we can cut a sodium or potassium with knife? Because these are soft in nature. Okay, so the first characteristic here, they are soft metals having low melting and boiling point. Okay, it should be clear to you that these should be soft, having a low melting and boiling point. What is the reason to have the low melting and boiling point? Okay, what is the reason to have a low melting and boiling point here? It depends upon what? The force of attraction. ठीक है, the point of the bonds which are present between the metals. Okay, now if the bonds would be weak, okay, then definitely the melting point will be low, and boiling point, it is depend upon type of interaction, that is van der Waal, etc. Okay, different type of force of attraction. So if that would be weak, then definitely boiling point will also be low. Now why these bonds should be? Because we already know in case of s block element, the outermost, it is having 1 or 2 electron only. So how many maximum bonds it can form? It can form only 1 or 2. Okay, in case of s block it can form 1 bond only, and in case of in case of group 1 it will form 1 bond only, and in case of group 2 it will form 2 bonds. So maximum 2 bonds. Okay, so that is the only reason that they are having less interaction, which leads to low melting and boiling point. Okay, the next point which you have to keep in mind, they have a low ionization enthalpy. First of all, before dealing with the characteristic, you must know what is ionization enthalpy. This you have learned in the 10th standard. The ionization enthalpy, the energy required to remove the electron. That the energy required to remove the electron. That is ionization enthalpy. In simple words, if I'll say, they have low. Why they have low? Because they are having in the outermost shell only 1 or 2 electron. So they can easily lose its electron. If they lose its electron easily, so definitely their ionization enthalpy would be low. But you can see here, when I'll say ns1, that means s orbital is having 1 electron. ठीक है, maximum electron that s orbital can accommodate, that is 2. So s orbital, when it is having a 1 electron only, so it is having the chances, because these metals are having the chances that they can give its 1 electron and attain a stable electronic configuration. When I'll say ns2, the s orbital is fully filled. So if I'll have to compare ns1 and ns2, that means group 1 and group 2, then I will say group 2 is having more ionization enthalpy as compared to group 1. But they have not discussed here. This is a part of s block, but I am telling you because you must know this thing. Okay, so I'm agree that they having low ionization enthalpy. But if I'll compare alkali group 1 and group 2 is alkaline. If I'll compare alkali and alkaline, that is group s block, they are the members of the s block. So alkali metals, they are having low as compared to alkaline, because alkaline, the elements would be, the s orbital would be fully filled. So in that case it is having little bit higher than that of alkali metal. But if I'll compare the whole s block, if I'll compare the whole s block family with the p, d, f block, then I'll say that they are definitely having low ionization enthalpy, because as we move from left to right, the chances to remove the electron, that decrease. Okay, why that decrease, that we will discuss in the next part of the chapter. Okay, so next one, they form univalent or bivalent. Who? S block. When they will form univalent, definitely the members of the group 1 is having outermost electron. Group 1 is having outermost electron, that is 1. Okay, so when it will lose its 1 electron, it will have 1 unit positive charge. When we are talking about group 2, they are having 2 electron in the outermost shell. So they usually, definitely they lose both of their electron, so they will form bivalent. So some of the members of the group 2, that is magnesium, calcium, when they will lose an electron, you already know magnesium is having 2 positive, calcium is having 2 positive, whereas in case of sodium it is having 1 positive, because these are the members of the group 1. Group 1, uni means 1, bi means 2. Okay, next one, fourth part, group 1 of s block is called alkali metal. Okay, group 1 of the s block is called alkali metal. Why we call group 1 as alkali metal? What are alkalis? You already know alkalis are the bases which are water soluble. This you have learnt in the previous classes. So why we call group 1 as alkali metal? Because these are the metals which you, when you dissolve in water, This you have learned. Sodium, potassium, when you will dissolve them in water, they react with the water and form hydroxide. That's why we named the whole group 1 as a alkali metal. And the next group 2 is called alkaline earth metal. Again, alkaline, that is a basic nature. Okay, earth, that means mostly the most of the metals of group 2 we usually obtain from earth crust, so that's why these are known as alkaline earth metal. The next one, they act as a reducing agent. Who? The S block elements, they act as a reducing agent. Why we see that? Because in case of S block element, they are having only 1 or 2 electron in their outermost shell. 1 or 2 electron in their outermost shell, so they can easily lose its electron. So when they easily lose its electron to others, definitely they oxidize themselves. Okay, oxidize itself, reduce other, so they act as a reducing agent. Okay, why they act as a reducing agent? Because they want to get stable like noble gases, and they could be stable just by losing the electron. If they are metals, definitely they will lose the electron, they will not gain the electron. You already know this thing. Metals are the substances which have a tendency to lose the electron, so that's why they are acting as a reducing agent. Next, they impart color. Means when you will heat the S block elements, okay, when you will heat the S block element, okay, on the flame, what you will observe over there? It will give you a characteristic flame. Okay, it will give you a characteristic flame. Why that characteristic flame? Due to, see, photoelectric effect. You have learned in the second unit, structure of atom. What is photoelectric? With the light, the sufficient of energy of sufficient energy is absorbed by electron, it will get excited from the lower energy level to the higher energy level, then again come back and emit radiation, which give a characteristic flame. So why that is so? Because the outermost electron is loosely bound, and that could be only in case of S block elements. They usually give characteristic flames. Okay, जैसे sodium usually give yellow flame, potassium give violet flame, so you can take the examples over there. Next part of the periodic table, that is P block. Okay, next part of the periodic table, that is a P block. Now where the P block would be? Again, if you have to assume this as a periodic table, I have already told you that this is this side. This side is what? This side include group 1 and 2, that is a S block. Okay, this would be D block. What is left? P. P would be on this side. That is totally the right side of the periodic table. This side we will say what is there? P block. Okay. Now, first of all, the electronic configuration of P. See, NS2 journal. Why we are saying again journal electronic configuration? Because N could be different, but the outermost electron while moving in the group could be same. So NS2 NP 126. So again N would be the principal quantum number. Okay, as you can see in case of P block, S orbital is totally filled. So what is there? P is changing from 1 to 6. You already know. See, P block element in which the last electron enters in the P orbital, we name them as a P block. Now it starts from group 13 to group 18. Group 13 to group 18 is a P block that is present on the right side of the periodic table. Okay, group 13 to group 18. Now in group 13, when we will start, then it will start with the P. Okay, P orbital. These are 3 P orbital. You have learned in the second chapter, structure of atom. P orbitals are 3. Okay, P, X, Y, Px, Py, Pz. 3 orbitals we are having. Okay, N could be different. So 3 orbital can contain how many electrons? 6 electrons. So that's why it is written 1 to 6. When I'll start with the group 13, suppose, then definitely how many electron would be there? P1 and P1. Okay, and P1 for the whole group. Group 14 and P2. Group 15 and P3. Next group 16 and P4. Next will be group 17 and P5. And for the last 18 group, जिसको हम noble gas बोलते हैं, it will be NP6. And P will be fully filled in case of this one. Okay. Now we will start with the characteristic of the P block. When we are doing the characteristic of the P block, the first thing you will learn here, that will be they include both metals and non-metals. Okay, they include both metals and non-metal. Why I am saying this, that they include both metals and non-metals? Because when you are moving from left to right of the periodic table, the size decrease, okay, the chances of the removing the electron will decrease, and the elements usually will attain stable electronic configuration, fully filled electronic configuration. So the chances for them to gain the electron, that will increase instead of losing the electron. And when it will be different, then definitely they will change from metal toward non-metal. Okay. So your it is, I have written over there, you have to keep in mind, while in case of p block, the metallic character decrease. Metallic character means their metallic nature decrease when we move from left to right. Okay, that means from group 13 to 18 metallic character decrease, and what will increase? Non-metallic character. Okay, while in a group, what I'm talking about, when you are moving in a group 13, group 14, group 15, group 16, that means you are moving from top to bottom. In that case, the metallic character will increase. Okay, next property of the p block, that will be the ionization enthalpy. Now ionization enthalpy is high as compared to s block. Why we will say that? That ionization enthalpy in case of p block is high as compared to s block, because s block is present on the left side of the periodic table, whereas p block is present on the right side. So when you will move from left to right, then what would be there? Size decrease, nuclear charge increase, so the chances to remove the electron will decrease definitely, which leads to what? High ionization enthalpy. So due to small size and high nuclear charge, reason is written over here. Next, they form covalent compounds. Why they form covalent compounds? Covalent bond, that is formed by sharing of electron. Okay, covalent bond, that is formed by sharing. So they prefer covalent compound. Why they prefer covalent? Because when I'm saying that they are changing from metallic toward non-metallic, that means instead of losing electron, they having a chances to get stabilize them. Okay, so by sharing electron. Okay, like you can talk about carbon here. Okay, carbon is having 4 electron in the outermost shell, so it is preferring to attain 4 electron more just by sharing instead of losing or gaining. Okay, so that's a concept here. Next one, show variable oxidation state. It is based on the different, it will be different for group 13, it will be different, group 14. When you will learn p block, okay, you are having a separate unit p block, so you will learn that which element show variable oxidation state. That is not the part of this unit. Next, group 18 is called noble gases. Group 18 of the p block, the last group of the periodic table, that is the noble gases, and that is a part of the p block. In that case, what would be there? See, in that case, the s orbital, the p orbital, okay, that would be fully filled. Okay, in that case, the p orbital, that will be fully filled. Okay, next will be group 17 and group 16. The group 17, that is known as halogen, that will include fluorine, chlorine, bromine, iodine. That is a halogen. And I'm written here also why we call group 17 as a halogen. Why we call them as a halogen? Because they form salt when react with metals. That's why group 17 is called as a halogen. Next one is group 16, that is known as a chalcogen, because most of them are obtained from sulfide or oxide. Means their ores are sulfide, or they are attached with sulfur or oxygen. That's why they are called chalcogen. In group 16, which family we will talk, that is about oxygen family. This is the oxygen family. Okay, and this is the halogen family, which is a fluorine, chlorine, bromine, iodine. Group 18 you already know, noble gases, helium. Next one, neon, argon, krypton, xenon. ठीक है बेटा. Next one. Now this is the main point which you have to keep in mind. Both S and P block elements are called representative elements. S and P element. Representative also, you can say normal element also. It could be written in your book also that they are called normal elements. Okay, that is also the same part. Why we usually name them as a representative element? It is written because all the elements of the group 1, group 2 and group 13 to 18. Group 13 to 18, that means a P block. Group 1 and 2, that means the S block. I'm just dictating it as a S block. Group 1 and 2, group P block, that is a group 13 to 18, have same electronic configuration. What is the meaning of same electronic configuration? That means when you will move from in a group 1, group 2, their principal quantum number will change, but the outer electronic configuration, that is same. जैसे for example when you talk about hydrogen to hydrogen, then lithium, then sodium, then potassium, in the outermost shell their principal quantum number change, that is 1s1, then 2s1, then 3s1, then 4s1, then 5s1. That means the principal quantum number change, but the outer electronic configuration is almost same, that is 1111. So in case of group 13 also, that will be p11111, and next group 14 p2222. Okay, so based on that, so that's why, because in while moving in a group they all are having same type of properties, so means they are not having same, but while moving in a group their elements having the same type of property, that's why they are called representative elements. Okay, the next third part, that is a d block elements. Now what are the d block elements? The elements in which the last electron enters in the d orbital. Okay, now that is known as a d orbital, d block elements. Okay, but see what I have written here, but penultimate energy level, it will enters in the d orbital but next to the valence shell. Okay, it will be enters in the d orbital but next to the valence shell. What is the meaning of the penultimate? The shell which is next inner, next to the valence shell but inside of the valence shell. See, the shell which is before the valence shell, the shell which is before the valence shell, it would be more clear to you when you will we will go for this concept. Okay, the shell which is next to the valence shell, usually the d orbital, d block elements are those in which the electrons are filled in the d orbital, no doubt is there. Okay, but the valence shell would be different, and the d orbital that is present next to it, that means inside of it. Okay, in that the electron is filled. I'm written here just to dictate you, just to make you understand that, for example, if n is the valence shell, if suppose n is the valence shell, so n minus 1, that means one number less than n, that will be its penultimate shell. See, now the question arises, definitely the question would be in your mind, that why in d block elements the electron enters in the penultimate shell. Okay, penultimate, why it not enters in the valence shell, why it enters in the penultimate shell? This is clear from the second unit. You have learned of a principle. So where we have learned the orbital are filled according to increasing energies. We have learned over there the orbitals are filled according to increasing energies. So if it is so, okay, if the orbitals are filled according to increasing energies, so we are having, you already know, 1s, 2s, 3s, okay, then 3p, then 4d, okay, then 4s, then 3d, then 4s come prior than that of 3d. Okay, when 4s come prior than that of 3d, so what is the conclusion from here? That 4s will be filled earlier than that of a 3d. Okay, 4s will be filled earlier than that of 3d. So from there what we reach to the conclusion, then definitely if 4s is the outermost shell, then d orbital will be filled afterward, 3 will be filled afterward, that is the next to the valence shell. Okay, so this is the up to a d block element. We are left with the f block and some of the concept of the d block. We will discuss that in the next video. Thank you for your cooperation.